The title of this project is called An Investigation of Techniques to Reduce the Thermal Contact Resistance of 3D Printed Materials. I'm Isaac Andron. My group members were Jesus Martinez, Craig Martin, and Eric Sisweda. To introduce you to this project, I'd like to talk about 3D printing, also known as additive manufacturing. 3D printing, as you may know, is the layer-by-layer creation of parts, which has become popular due to its accuracy, repeatability, and effectiveness. However, the layers introduce void spaces and ridges, which complicate thermal conductivity. Slight warping can also occur during the curing process. All of this can introduce excessive contact resistance. This would be problematic for applications requiring efficient heat transfer, such as 3D printed heat exchangers, which have recently been fabricated. So what is thermal contact resistance? It contributes to the temperature drop between materials and is caused by gaps between them. This report attempts to address this by using adhesives. Other methods of reducing contact resistance include sanding or filing, acetone vapor treatment, and potassium hydroxide etching, which all have disadvantages. On to the methodology. We investigated the contact resistance between 3D printed materials and aluminum, glass, and wood. The adhesive used were glue stick, all-purpose glue, and superglue. The first sample included wood, glass, aluminum, and 3D printed resin. Here's a schematic showing the configuration and dimensions of the sample, as well as its thermal circuit. Sample 2 included wood, aluminum, glass, and the 3D printed resin. And circuit diagram for sample 2. Sample 3 included aluminum, glass, and the 3D printed resin. Here are the schematic and diagram for sample 3. This is a list of equipment used during the experiment. The experimental procedure was to set the hot plate to a standard temperature and place the sample on the hot plate. After the temperature stabilized, several measurements were taken. The average temperature was then recorded for each sample and for each trial. The samples were thoroughly cleaned to remove traces of the previously used adhesive in between each trial. On to the results. Here is a table with the recorded temperatures. And here you can see a chart displaying the average increase in temperature compared to no adhesive for glue stick, all-purpose glue, and superglue. In conclusion, the results indicate that commonly available adhesives tested do indeed reduce the temperature drop due to thermal contact resistance in 3D printed materials. Among the 3 adhesives tested, Elmer's all-purpose glue provided the largest impact. This impact was limited, however, to less than 2 degrees Celsius on average. In the future, other adhesives should be investigated, such as conductive nickel paint, which has a high thermal conductivity of its own. Here are some of my references, and that is the end of the video.